Okay, we got 3 questions sent in from the Math 110. These questions are from 4.2, 4.3, and the first one is 4.239/13. So it's number 39 in the book, number 13 online. And this question is asking, sketch the graph of the rational function. Okay? Sketch the graph of the rational function. Okay, so we got 2 things going on here. One is we need to find the vertical asymptote and we need to find the horizontal asymptote. The good news is that you've already factored it on the bottom, so that means that you know what the vertical asymptote is because of what we went over in the last set of questions. Whenever you want to find the vertical asymptote, you set the denominator equal to 0. And hold on, my whiteboard is not up here. There we go. So, and I wrote this down in the last set of questions. To find the vertical asymptote, set denominator or radicand equal to 0. Remember me saying that the domain is only affected when you have a fraction or a radical? You got to set the denominator or the radicand equal to 0 and solve. So in this case, you've already got it factored, so you don't have to do the factoring. X plus 2 and x minus 4 is equal to 0. Now we know that for anything to be 0, one of the products or one of the terms has to be 0 for this to come out to be 0. 4 times 0 is 0. 2 times 0 is 0. 0 times 5 is 0. So one of these has to be 0. So I'm going to go ahead and set both of them equal to 0. And we get a -2 and a +4. So so if I was to sketch this out, I know I got a vertical asymptote at -2 and at +4. We also know, and we'll go ahead and just for right now, you go ahead and use your FOIL method, and let's go ahead and see what this looks like. It's equal to x squared, and that's going to be a minus plus 2x minus 3, using our FOIL method. X squared minus 4x be a minus 2x and -8. Now, when these two are the same, see the degrees of those two? They're the same. And there's a test in your book. You have to look through your book. I'm not going to look for it for you. But it tells you how to find the horizontal asymptotes. And the horizontal asymptote, in this case, is going to be 3/8. Okay? It should be 3/8. I think it's 3/8 because this pretty much goes out and you're left with 3/8. If you have the same degree, I said this in the last video, if the degree of the numerator is equal to the degree of the denominator, if they're equal, which they are, because you got an x to the second and x to the second, they're equal, then you just plug 0 in, and whatever's left is your horizontal asymptote. So plug 0 in, you're left with 3/8. 3/8 equals your horizontal asymptote. So 3/8 is about 1/3. So there's 1, 2, 3, 1/3 would be right in there. So you're looking for a graph with 2 vertical asymptotes and 1 horizontal asymptote, let me just use the highlighter. You're looking for a graph that has two vertical asymptotes and one horizontal asymptote at 3/8, which is about 1/3. So this one has two, but it has below, so that one's not right. This one has two, but it has the horizontal asymptote being 0. That's not right. Same thing here, 0. That's not right. But this one, it has two horizontal asymptotes and has at 1/3, it has the horizontal asymptote. So here, you don't even have to graph the function. All you have to do is find the vertical asymptotes. And like I said in the last virtual office hours video, you have to set the denominator or the radicand equal to 0. Okay, so this comes from the last video, and this, where I just used the FOIL method, that's from just basic algebra. And this came from the last video also. There's a page in the book, I don't know where it is, but like I said, I'll go through it again. If the degree of the numerator is more than the degree of the denominator, then you use long division. And either you're going to have a vertical asymptote or the vertical asymptote is going to be an oblique asymptote. It's going to turn out to be an oblique asymptote. If the degree of the numerator is equal to the degree of the denominator, then you just use the coefficients. Plug in 0 for x, and whatever's left is the coefficient. In this case, it was 3/8, because -3 over -8 is 3/8, positive 3/8. And if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is equal to 0. Okay? And I told you in the book, it's in the book, it's a box, I want to say it's a bluish gray box in the middle of the page, and it has tests for vertical and horizontal asymptotes. And to find the vertical asymptote, you either set the denominator or the radicand equal to 0, and that's where the vertical asymptotes are. So I hope that helps. Let's go to the next question. Next question is 4.3.17.5. 4.3.17.5. Find all complex solutions for the following equation by hand. Ooh, what a mess. First of all, we're going to rearrange it first, because I have no idea. The way it looks right now, the first thing you're going to do is rearrange it. So I'm going to rearrange it and put 30 over x squared minus 11 over x plus 1 is equal to 0. Okay? Another thing I'm going to do is I'm going to rewrite it and say 30x to the -2 minus 11x to the -1 plus 1 is equal to 0. Now, we know it's going to be open and downward. I'm kind of confused on what the question's asking, but we'll go ahead and work it out. Let me work it out on paper first. Hold on just a second. Let me work it out on paper. I'm going to pause the video so we won't waste video. Hold on just a second.